Okay, so having reviewed the principles of long division and synthetic division, if you need more information on that, go back to our material that we covered when we were covering it in the intermediate algebra textbook. In this case, we're interested in what's called the division algorithm of polynomials. And we're given this statement in the book. We're told to let p of x and d of x be polynomials, where d of x is of a lower degree than p of x, and d of x is a degree 1 or more polynomial. Then there exists a unique polynomial q of x and r of x such that p of x equals d of x times q of x plus r of x, where r of x is either 0 or of a degree less than d of x, and the polynomial p of x is called the dividend, d of x is the divisor, q of x is the quotient, and r of x is the remainder. Okay, that's a mouthful to say, but let's explore what this actually means right here by starting with a polynomial. And we know how this polynomial division would work. I mean, we've done the long division and synthetic division in the past, and we know how that should work out. What does all of this stuff mean? Well, let's rewrite this just a little bit. First of all, if I'm going to do a polynomial division, I need to make sure that p of x, this is what this is, p of x, the divisor, the dividend, is in descending order over d of x, which is our divisor. So in this case, we really have, let me go ahead and put this in black, the polynomial x to the fourth minus 2x cubed minus 7x minus 110 in descending order divided by x minus 4. And in this case, we would be saying that we're taking the divisor, the dividend, p of x, and dividing it by our divisor, d of x, right here. And if you recall, our division, when we talked about it before, went like this. If we took the polynomial, divided it by our divisor d of x, we were going to somehow find a quotient q of x plus a remainder, and we'll call the remainder r of x, whatever that remainder polynomial is, divided by d of x, the divisor. Right? If you recall, that was our statement from the previous page. Right here, right? Dividend over divisor is equal to quotient plus remainder over divisor. Only in this case, we're calling them p of x, q of x, d of x, and r of x in place of dividend, divisor, quotient, remainder, divisor. Okay. Well, what did they do? Well, if you treat this like any other rational equation, we're taking a polynomial divided by a polynomial, and we recall very well that we should be multiplying through by the LCD to clear the fraction. So let me do that really quickly with this algorithm. If I take d of x and multiply it by both sides of this equation, observe what happens. D of x times p of x over d of x is equal to d of x times q of x plus r of x over d of x, right? And that's d of x, when we multiply d of x, that's d of x over 1, right? Not d of x that gets multiplied in the numerator denominator. Remember, it's numerator to numerator, denominator to denominator. And on the left-hand side, d of x just simply cancels out. By the way, on the right-hand side, when we multiply d of x after distributing it to the second term, d of x also cancels out from this denominator right here. So what are we left with? But p of x on the left-hand side of our equation, d of x times q of x plus r of x. And that is our division algorithm. All right, so let's see how that works out right here. We're told to express the solution using the division algorithm shown above. That's in this form right here. So how will that work out? Well, I'll just carry out the synthetic division right here since we already know what's going on with that. I'm going to divide by x minus 4. I know that x minus 4 is equal to 0 at positive 4. I change the sign for my synthetic division setup. I put in each of my coefficients here from p of x. So in this case, it's 1x to the fourth. It's negative 2x cubed. It's 0x squared. Don't forget your placeholder. Minus 7x minus 110 as the constant. And now we're going to carry out the synthetic division. Carry down the 1 directly, the leading coefficient. Multiply 4 times 1. Bring that result up. And then add down the column. 4 added to negative 2 gives me positive 2. 4 times 2 gives me 8. Added to 0 gives me 8. 4 times 8 is 32. 32 minus 7 gives me 25. And 4 times 25 gives me 100. Adding down the column, my remainder is negative 10. And so this is my remainder right here. And my remainder is just going to be a number, negative 10. Does that work? Well, we're saying then that r of x, our remainder, is equal to negative 10. That's it. We can consider that a polynomial. Negative 10, right? A whole number can be a polynomial. It's a 0th degree polynomial, but it still works. So by this division algorithm, what should work out is that p of x, x to the fourth, minus 2x cubed, minus 7x, minus 110 will be exactly equal to the quantity x minus 4, our divisor, times our, right over here, quotient q of x, right? Q of x is represented by these coefficients. So q of x, which would be x to the third, 1 degree less than what we started out with for p of x, plus 2x squared, plus 8x, plus 25. All of that added to our remainder function, r of x, which is in this case minus 10. Right? If you think about what this actually means, right, if we were to divide all sides right here by x minus 4, this is really the same thing as saying x to the fourth minus 2x cubed minus 7x minus 110 divided by x minus 4 would be equal to x cubed plus 2x squared plus 8x plus 25 minus 10 over x minus 4. Only in this case, we've rearranged that equation, just like we did right here in this explanation. Right? And by the way, and you should do this as an exercise, carry out the multiplication. X minus 4 times x cubed plus 2x squared plus 8x minus 25, then subtract 10, and you should get x to the fourth minus 2x cubed minus 7x minus 10. And just one quick note here before we end this up. Why does it work out that way? Well, if we go back to just a simple numerical example, if I took 130 and divided that by 12, what would happen? Well, 12 goes into 130 by division. 12 goes into 130 once for 13. Subtract. Gives us 1, 0. 12 goes into 10 0 times. So we subtract 0, and of course that's our remainder is 10, right? So we could say that 130 is the same thing as 10 added to 10/12 if we wanted to express it that way. Or alternatively, we could have stated that 130 is the result of 12 times 10 plus 10 more, which should make some sense to you because 12 times 10 is 120, and 10 more does give us 130 as promised. All right, so this algorithm should make some sense to you in that regard. Okay, more in the next video.